Hi, everyone. My name is Flora Roumpani. Some of you may know me from the very first CityEngine user meetings. Sadly, there was a break for me the last 3 years or so, but I've decided to come back today as I'm engaging back into projects with CityEngine. We're actually starting now. So yeah, today I'm going to talk a little bit about a project that we did with the research center I'm working on, and it's about automating the planning system using AI. First, a bit about me. So I'm an architect, I'm a researcher, and I'm also teaching in a university in the UK. I'm based in the UK, so I'm a research associate at the Alan Turing Institute. I'm teaching in the Royal College of Art, and I'm also an engineer in Borough Happel, where we're doing digital twin stuff and kind of like a little bit of everything. But the main thing is that I did my PhD in CityEngine, so I use CityEngine to generate procedural buildings and join them with urban analytics, so dynamic urban models that predict land uses and things like that, and how can we visualize these using CityEngine. I had presented that in a previous meeting. But yeah, I'll talk a little bit about this project, which we did with the Alan Turing Institute. So the Alan Turing Institute is the UK's National Centre for Artificial Intelligence. It sounds very, very prestigious because of the name. It sort of is. It's it has 5 founding universities: Oxford, Cambridge, UCL, Warwick, and I forget the fifth one. There's a lot of academics who are involved in this. They're starting to engage companies as well. And it's a very vibrant and innovative place, especially for young researchers, postdocs, or people who have done PhDs to just go there and just, it's a melting pot of ideas. And they focus exclusively in AI and how can AI help the world, how can it make the world a better place. Everything is open source, and that's the whole concept of it. And it focuses on health, sustainability, climate change, urban resilience, and security and privacy. So all of these things at once. Obviously, I'm part of the urban part. Yeah, these are some of the projects that currently the Turing is working on. It's like a lot of diversity stuff, a lot of sustainability in the Arctic, very specialized stuff and very fragmented because AI at the moment is a bit focused on very specific things. A very quick question. How many of you have used AI or machine learning in any of your projects, whether that's CityEngine or whether that's data or whether that's classification of stuff? Yeah, okay. That's quite a few, okay. Brilliant. Okay. And how many, have you used it more for optimizing? How many have you done optimization of software using AI?
Code.
Sorry?
Code generation stuff or the content optimization?
Content, both, either one.
It's just the Copilot stuff.
Copilot, yeah. And how many did you use it for? Data analysis or classification, things like that? Yep. What was it about, if you don't mind?
Using my models to figure out information from already developed reports and get data from specific reports, so specific database, and using my models to extract the data from those specific
from text, right? And then yeah. Cool. Anyone else who's done something different? Cool. Okay, so yeah, image, yeah. Image classification and and recognizing objects and so on. Perfect. Yeah. Okay. Exactly. Yeah. So when we talk about AI for cities, we kind of have this kind of feeling. Elon Musk has kind of planting chips in our brain and getting data and supposedly controlling stuff. And now they have a test trial and so on. And AI for cities is a big topic. It's getting a lot of funding in academia. Like AI for cities is going to take over the world or whatever. The reality of the situation is that at the moment, in most organizations, AI for cities looks a bit like this. Well, actually, exactly like this. Is more used to kind of find patterns, image recognition, and it's actually not very good as well. It needs a lot of training. We're not there yet at the moment. What I'm going to show today is how we extracted data in order, hopefully, to do to create 3D models from very, very basic data from planning applications. So in the Alan Turing Institute, we have something that's called the data study groups. The data study groups are like intense hackathons that they call researchers, data analysts, and other people from all around the UK or the world to work on specific problems. One of the study group that we organized was precisely this, was to try to get planning applications and see if we can extract information using AI and then use that in order to create 3D buildings. It didn't get too far, but bear with me. So we just had a chat before about how do you actually submit plans for planning applications in the UK. And something that kind of struck me is that I was saying that you're actually using, in Switzerland, you're using a format of CityGML to submit planning application, and it's mandatory. In the UK, you don't have that. In the UK, you submit planning applications using PDFs. So basically, it's very, very sophisticated AI stuff. So basically, and also each ward has its own system of submitting planning applications. So it could be something like people doing things in CAD and then just submitting them, exporting them in PDF, submitting them, or people actually doing manual drawings with their hands, just handwriting stuff and then submitting them. And they don't even have a specific format, so it could contain like one ground floor, like 100 ground floors, or like 500 drawings in the same page and submitting them. What happens now is that there is this huge archive of planning applications, of drawings of buildings that show the evolution of the city from ever since that started like 100 years ago or so. That is not being used at all. So we have this information. We could use it to extract incredibly meaningful information. We could extract it to see how the evolution of the city goes dynamically, what has been demolished, what is being built, what kind of extensions have been built, even trees, but we can't use it. So the concept of this project is, can we actually use AI to read these? Can we extract this information? Can we do anything with it? So a bit of information. So as I'm sure you know, AI needs data. If you don't have data, you can't work. You can't do anything. In the UK, every year we have 3.5 million applications being submitted. That means that each person in the UK, each public servant in the UK who checks application, they need about 2 million man hours in order to read all these applications and check whether something is right or wrong, whatever that may be. And there is a 3-week delay for application processing. So it takes about 3 weeks for somebody to read it and see whether that something is right or wrong. So we have 40% of these applications being rejected. 80% of them are rejected by simply 12 simple mistakes. which are, and the 5 most common mistakes are that they're submitting a wrong application form, they're putting the wrong application fee, they don't have any supporting documents, there's no scale in the drawings, and there is no north sign, apparently, which is kind of ridiculous. But yeah, it happens. So the concept is twofold, actually. A, we can read this planning applications to read drawings to see if we can make 3D buildings out of it. The second is can we actually speed up the to this process of looking into planning applications to find the common mistakes and inform people and save public servants time by kind of detecting this errors real time. So what we did is that we got planning application data from the Borough of Redbridge in the UK. It's about 1,800K planning applications. These are in multiple forms and drawings, PDFs again. There's a big variety across applications. As I said before, you got like all these weird stuff where you can have like multiple drawings in one page. Yeah, you have like things that don't even have a north sign or like legend or whatever, and then there's a building, a handwritten stuff here. There's a large variety of really unstructured data and also, yeah, a big mess, basically. So what can we do? Can we use AI to automate categorize the type of content planning applications PDF? So we started doing this. We took those PDFs and we divided them into 2 parts, the application form, which is text, and the drawings, which are drawings. From the text data, we did a metadata analysis. And from the building plans, we extract the label plans, and well, we did a further analysis. So let me start with the first one, text analytics. I'm going to go very fast on this one because it's not very interesting probably for this presentation, but the planning applications, the text analysis from the handwritten forms, we extracted this information. We got what's kind of like the major letters that appear, target distribution of PDFs files. So how many of the PDFs have plans on it? How many have text or the application? How many have other stuff on it? And then we started extracting the metadata. I think some of the most interesting results were this. So this is a distribution of handwritten application forms versus the digitized application forms. So yeah, it's quite easy to understand how many of these forms are plans and how many are texts by simply just counting the number of words. And we can just separate them very fast like that. Yeah, so then we can simply check what's the ratio between images that are being detected and texts. And also we can submit information for that as to whether that's a form or whether that's a drawing. Yeah, similarly here, again, the length extract for PDF, average image area per page, documents more likely to include scanned images go in this section, documents less likely to include scanned images go in this section. And that was quite interesting, actually. There were clusters of drawings of where you can find drawings, and we could categorize what type of form that is based on where it clusters, whether that's just a fully details of the person, or whether that's a ground plan, or whether that's different types of, yeah. So I'm going to go to the interesting part now. Detecting components in planning drawings. So the question is, okay, we have all these PDFs that have all these drawings. They could be hand-drawn, they could be anything. How can we use AI to detect that? And it's actually let's see. Yeah, it's very much like the kangaroos here. So what we did here is that we started labeling drawings, and we started saying that, so we use like a supervised learning method. We started saying what are the drawings, which parts are the drawings and which parts are the text, which parts are empty spaces, and we started training the model, which was based on a Coco data set. It's called, we use something that's called MaskCRN, and now it's kind of like much better techniques now, but never mind. We started looking at, okay, can we actually, the same way that we can detect kangaroos, can we detect drawings and extract information from it? Turn and kind of see whether that something is approved or not, whether we can detect whether it has a north sign, whether we can detect whether it has like all the information needed and automatically approved it or not. So we got, we just, in the hackathon that we did, we just got 30 images, so not that many images. We labeled them, which means that we kind of selected certain elements and we classified them based on what we viewed, and then we ran the model, and it turns out it works quite well. So it turns out that the AI actually detects what's a drawing, what's a block title, what's a drawing title, and what's a north sign as well, and the scale as well if we kind of go a bit further up. So it's actually quite straightforward and easy to in a few steps to be able to detect and kind of signal whether something is missing something or is not missing something. Going beyond that, we were able to cluster the different types of drawings by assigning the drawing to the label underneath it or to whatever it is nearby. So then we were able to know that this is a floor plan and which floor plan it is, what is the front, the facade, the sections and so on. By having that, we were able to relay drawings to captions and identify both common errors and submissions. So yeah, I'm just going to go very fast here and say that how we kind of were able to identify which plan is which. Yeah, and then the next steps, which we're working at the moment with the Alan Turing Institute of Boer Huppold, is, okay, we've done that, we've clustered them, we have them in folders. We need to start reading each and every plan to create the primitives, and then maybe see if we can use CityEngine to start building up the entire history of the UK from the moment they started the planning applications until now. Bit ambitious, but we'll see how far we get. So yeah, that's the plan. If you have any questions, or if you have anybody would like to be involved, it's like a research institution which has a lot of possibilities for collaborations and fundings and things like that. So please do get in touch. There is a report, if you want to read it, that describes in detail what we're doing and what we did. You can find it online. It's this one here, Data Study Group Report Agile Data. So yeah, feel free to read that one. And also get in touch if you want to, if you have any questions or you'd like to be part of it and collaborate. So thank you. Any questions?
I was just wondering, how do you plan or how do you extract the attributes in order to drive the procedural model from these plans? Do you look for some numbers or labels somewhere on the plans?
Yeah, we're in this process right now, actually. So we're restarting the project. We are looking for numbers originally, so from dimensions and things like that. But effectively, what we're trying to do is read the first thing to do is read the lines, turn them to vectors, replicate the outline, and then also start building the rooms with dimensions and everything like that. Yeah, for what's its use of each area or whatever that may be, we do something quite a bit how do you say, like is not the right method of doing it. It's kind of, we're cheating a bit. So what we do is that usually in the drawing plans, not usually because, usually you have a description that is near, whether inside a certain area or underneath it. So what we do is that we try to look, once we kind of find we find the boundary of the object, we look for text near it, and then we find all the text, and we start assigning the closest text to that object. And once it gets assigned, we remove it from the list. So then we go to the next object. We see that, and we remove it from the list. We attach it, and we remove it from this. This is how we usually do that information. For other attributes, we read using OCR and try to automatize the process, which we haven't got to that point yet.
Thank you.
Okay. Yeah.
Hey, great presentation.
Thank you.
I just seeing the training of that was really eye-opening, and then ending up in CityEngine. I was curious if in the future, I guess I have a couple future questions, but if you were looking at maybe for things that are missing, say a north scale, if it can start to identify the context of those models. I've worked in planning and had the same experience where we're getting PDFs and I'm trying to figure out what building on the edge of the lot I can georeference to. And so maybe is that something that you can potentially train it to add the context to these models as well?
So when you're saying context, can you give me an example of the...
So, yeah, you had a building there, and there was no street edge to it, and there was no other surrounding buildings. And so being able to add a north scale to it, or a north symbol and scale to it, and be able to georeference it as to where it should be.
Oh, right. Yeah, I see what you mean. Yeah, I think that's definitely doable in the long term. Very far in the long term. I think at the moment it's crucial to pin down whether AI can help us identify the mistakes, like going like, okay, this is missing the north sign. This is missing the context of where it is, the location, the geolocation. We don't have the geolocation. Okay. But it can do that because there are multiple documents submitted, and once an application is passed, it means that it has all this information. And so I guess a good idea, which actually you've given me a very good idea, is to start combining documents and creating like a mosaic, of the information, and then maybe, just put a north arrow where it's missing or something like that. That would have been really interesting.
Okay. Well, I also had another question regarding the historic documents that you're going through. Are you also finding that a lot of the historic architecture or developments are out of line with the current zoning or regulatory recommendations? And is that something that you're hoping to hide or to flag?
Yeah. Oh, that's a good point. Haven't thought about that. I'm assuming that I haven't seen the content actually of those old drawings. I don't know if it's going to start showing stuff that shouldn't have been done or things like that. It's possible that it will. Yeah. That would be interesting as well. From a research point of view, that would be very, very interesting. I'm not sure what will that do in the planning.
I'll sign up for the next PhD program.
It may cause a bit of a controversy. But yeah, I think that possibly one of the most interesting thing that we're going to start seeing is what has been demolished and how much of the growth has starting to take place in different areas of the UK, and with what time did these happen? So where, yeah, we may run into a situation where things should not happen, and so on. So yeah, that's something that definitely we need to consider.
Oh, nice work.
Yeah.
Thank you.
Thank you very much. Thank you.
So another question in terms more like design process. What's about, for example, importing shapefile from ArcGIS as a proposal, as a building footprint, and add some mood photos, reference photos with number of floors, and play around how that could work?
So you mean, so whether we can combine the PDFs with, let's say...
So instead of using historical data, working on a proposal, like importing shapefile footprint with as a georeference in a, let's say, vacant area, and continue the same, basically, rule or whatever we call it, using AI.
Oh, so...
To generate, basically, proposal building on a delivered shapefile footprint.
To generate proposal in the delivered, I'm not sure I understand.
So what I mean, like basically your data is searching, AI in the data searching for the delivered PDFs with all views of the building. So instead of that, add proposal building footprint and some mood photos, like to let AI to generate artificial generated proposal building as a project.
Ah, okay. That would be interesting. So to start looking
at a little bit different point of view from, let's say, behind or whatever. Yeah, but anyway, I believe it's achievable. Yeah,
it is. Yeah, it sounds like it's achievable, and it's a good idea actually. So definitely could consider that. So thank you. Yeah. Cool. Oh.
Hello, Flora, and thank you for the presentation. It was really cool, especially that part about the growth of the UK over a period of time. There was a thing at the end that you had there that was really interesting for me, which was the textures of a 3D mesh.
Yeah.
What way do you guys foresee that going in the future? Is that an AI type of thing, or is that something that, I don't know, what way are you going to do it?
That's
very open.
That's a very good question, and it's something that I'd like your input here from the CityEngine community, because CityEngine is kind of famous for doing generating facades. One idea is to start using planning rules to generate approximations of facades. So there was a project that we did a while ago where we tried to generate the Victorian house. The facade of the Victorian house, and that was by integrating planning regulations from the 1810 to the. I mean, the Victorian house has very specific ways, rules of how it's generated, and has a very specific span. So from 1810 to 1830, there's a very specific typology. Then from 1830 to 1850 is another specific typology, and so on. So we tried to do one of them. Using these regulations of how the bay is structured and what's in relation to the footprint and so on. And what we came across was that, so we worked with a lot of people from historians and people who are specialized in typologies and things like that. And we've kind of created some rules, then we generate a lot of variations, and we use the blueprint method, where we kind of showed them all these variations, and they were like, yeah, this does not exist. This exists. This does not exist. This exists. And we started kind of refining again and again the rule set to kind of have a more accurate, sort of accurate, semi-accurate representation of these facades. So that's one kind of way of starting looking into generating facades, by looking into how were the windows structured for each period of time. And again, we're not that interested in creating exactly accurate facades that you would see in drawings. In this case, we're interested into creating approximated, especially when it comes to planning, because we're more interested about planning. So if we can get information, for example, from the drawings from the facades of how many windows there are there and how much light does it go through in terms of that, then we can just create, it doesn't matter if it's a bit to the left or to the right or whatever. If we can just have that so that we can measure the energy energy stuff, or or how materials and things like that. We can extract materials and we can just add materials. That's an idea, but we're still thinking about that. So if you have any ideas, I'm happy to hear opinions. Cool. Thank you very much. Thank you.